And we are here again, and our next speaker is Adam Sandor. Hi, Adam.
Hello, hi there. Shall I just start? Okay.
Adam is from Container Solutions company. He will talk to us about GitOps and how GitOps changes our traditional approaches. Adam, would you say a couple of words about yourself and what you do in the company and what your company does?
Sure. So I work as a consultant, basically, in the area of cloud native and Container Solutions is a consultancy. So we help other companies adopt cloud technologies, migrate to public cloud services, build private clouds, and so on. And originally, my background is in Java development, and then I moved into this cool new space of cloud technology a few years ago.
Well, during that time, I think you gathered a lot of experience in what's going on. And why GitOps? Why I see you talk a lot about GitOps recently, and why this topic specifically?
Oh yeah, that's we started using GitOps on about 2 years ago on our projects, but really not as a big deal, more like a tool that is useful. It's nice. It solves some problems. But since then, actually, it's starting to have more and more impact. People are interested in it and so on. So I actually keep talking about it because there is just so much interest in it, and it is actually a very, very cool way to improve your CI/CD processes. So this is going to be the whole talk about, so I'm not going to say more.
Thanks. And would you talk to us about how often you present on the conferences, and how do you find that new online format that we've all had to move to recently?
Well, I think about a talk every month, let's say. So I don't do a huge amount of them, but I do plenty. And about the online conferences, well, I would love to be in Novosibirsk right now, meeting you guys, spending some time together. So that's definitely the downside of online conferences. On the other hand, I would maybe not be at Novosibirsk right now because it's just hard and expensive to get speakers from Amsterdam to Novosibirsk. So in this sense, it's the good thing about virtual conferences that I can just show up at your conference from the comfort of my living room and still share some knowledge and be there with you guys a little bit. So I'm not saying this is bad, just different.
And that's cool. We're super happy to have you with us. I think we can start with your presentation now.
Great. All right. Let me get started here. So, with the introductions done, I'm going to be talking about GitOps today, both covering the basics and basically showing how it really can make a big difference in how you build CI/CD systems. Let's jump into it. Before I completely jump into it, I would like to mention our book, Cloud Native Transformations, which was written by the two founders of Container Solutions. It's a book about high-level patterns on how to migrate to cloud native, and it's really useful as a guidebook to getting all the parts of a cloud native transformation right. And these patterns are also up on the cnpatterns.org website. We are trying to make this an open source project where others are also contributing. but the patterns with the whole story together are in this book. So today's story begins with a large German enterprise company who has been around for a long time and is starting to get worried about their aging technology, about how everything takes very long time. Releasing a new version of their best application takes 6 to 12 months. So the business is very slow to respond to new market pressure. So large German enterprise companies start thinking that maybe if we moved to the cloud, we would be more agile, we could build software faster, we could beat our competitors. So they start brainstorming. We'll do microservices in the cloud, we will run them on Kubernetes, we'll use all the cool new technologies. And they invited us as consultants to help them with this migration. And the first thing that we saw about their plans was that they did not think about how to do actually fast software delivery, how to do continuous delivery, and these kind of these agile processes. They were very focused on application architecture and cloud tooling. And that we were warning them that if you go down this route, you will end up building a distributed monolith that will be microservices, but you'll still not be able to release it very fast. But then we had an interesting discussion. They told us that, yeah, guys, very nice continuous delivery, of course. We thought about that, but we are a large German enterprise company and we have change management processes, we have compliance requirements, we are audited by the government, we need to be very, very secure. So how do we, if we start releasing software to production every week then or every day, then this is going to be chaos. And so we started thinking together with them how to get code to production in a single day. And we wanted to do this in as simple a way as possible, because many people at larger enterprise company had this reflex of, okay, let's start building some amazing release management system that sounded like we will be still building it 2 years later. So before we jump into what we came up with, let's take a look at what really continuous delivery means. The basic principle of continuous delivery is that you release software often and you get it to production as fast as possible. That means you will automate a lot, your deployments will need to be automated, most of your testing will need to be automated, and you have to really merge feature branches back into master as often as possible, for hopefully more than once a day. And then this process needs to run really fast, and you are basically mitigating risk by releasing often instead of by releasing infrequently. If we add CI to this and just look at the whole process, basically the CI process will compile the code and produce a Docker image in, of course, Kubernetes Cloudland. This whole talk will be all focused on Kubernetes. So hopefully everybody is at least a bit familiar with Kubernetes. So a Docker image gets built, gets pushed to the registry, and then the continuous delivery process kicks in and deploys it to a test environment where tests get run, and then deploys to production and then keeps monitoring it. If we add Kubernetes to this picture, we will see that the whole process doesn't change, but the deployment steps will be affected heavily by Kubernetes. So deployment will actually mean creating resources on Kubernetes, creating deployment and service resource and all kinds of other resources that the application might need. If we zoom in a little bit on this, on these deployment steps, we will see how this looks like in more detail. The deployment part is actually applying Kubernetes resource definitions here with kubectl, the Kubernetes client tool, where, let's say, in our deployment YAML file, we will have specified what kind of image are we deploying, and then we'll have other YAML files defining other resources that I don't need to go in now. But all these YAML files will be applied to the cluster through the Kubernetes API by kubectl, where then Kubernetes will deploy the actual image that needs to be deployed and will run it. So this is how this deployment process works on Kubernetes. And here are these YAML files. And the important thing today to take away from these YAML files is A, if you start using Kubernetes, you will be YAML developers. You will become YAML developers. And B, these are all declarative files, meaning you don't tell Kubernetes to start up this application. If something happens to it, then restart the application. No, you tell Kubernetes, I want to run the 1.14.2 version of app 1. All the rest of the stuff is taken care by Kubernetes. It also means you can apply this file 3 times to Kubernetes. It doesn't matter to Kubernetes how many times you apply it, because it just updates the definition of what it needs to run. If nothing has changed, Kubernetes doesn't change anything. If the image version has changed, Kubernetes will start running the upgrade process from one version of the image to the next. So this aspect of Kubernetes that we're working with fully declarative files is really, really important for GitOps, which we will get around in a bit, like right now. So adding GitOps to this picture, you can see that very little has actually changed, seemingly. We only added Git here, basically putting all our YAML files into version control. And whenever we're, from now on, when we want to change something, we are not just running kubectl apply ourselves, but we will be committing files to Git, or even better, we'll be creating pull requests that then somebody reviews and applies. And kubectl will be ran by an automated process that triggers whenever Git changes. So with GitOps, again, zooming out a bit and adding the whole CI part to it. So after the CI is done, the CI process will actually end with updating Git. Because of course, when we created an image, we also want to deploy it. And in a proper continuous delivery process, we always want to deploy our images. We don't just build images for fun. We want to immediately run them through the continuous delivery process and hopefully push them all the way to production. So the CI process would create a pull request, and maybe if we want a fully automated deployment, then it will also merge the pull request. So it will completely automated way update Git, and then the deployment will happen. So if we want a more controlled process, where we, let's say, for deploying to production, and this is what large German enterprise company needed for their change management and compliance processes, we can have a process using GitOps where development will create a pull request to update the version of the application here, and ops will be the ones who are able to merge the pull request to actually make the change happen. So this whole this change management and collaboration process on changing the production environment will all happen using purely Git. And this is very, very powerful because it is very cheap, because everybody already has a Git server running and all the source code is in there. This Git server is probably pretty highly available. It's pretty secure. So it's a trusted component inside an enterprise company or any kind of company. And we are just utilizing this Git system to do our change and release management. So what did we gain by using Git for this? we immediately get a change log because of Git commits. So Git commits will have a log of all our changes. We know who made the change and why, because Git knows that too. There are commit messages. We have a change review process using pull requests. We have user access control just using the Git server's user access control. And we have a central source of truth for what is the intended state of an environment. So we can just look at Git and, let's say, do an audit of what we deployed where and when. At least what was the intended state, because of course there might be a failure in the deployment, but that's a bit of a detailed topic. And finally, if we zoom out completely and take a look at the whole company level on what happens when we start using GitOps for our change and release management, suddenly the whole company's layout kind of changes. So in our case, we have multiple data centers and each data center running multiple Kubernetes clusters. So it's a pretty complex scenario. There are firewalls between these data centers and whatever. So it's not easy to communicate between them. It's not easy to have a central component also managing all these data centers. With GitOps, we can have a very robust distributed system for managing all our changes to these environments. Basically, instead of pushing changes to environments, we will be pulling changes into environments. Each Kubernetes cluster in each data center will be running a component that is doing the synchronization between the Git repository and the different Kubernetes namespaces. So let's say test repo 1 will be controlling what happens in test 1 namespace. And this tool here that I will be talking about in more detail in a bit will be controlling this synchronization process. It's actually very simple. When something changes in this Git repository here, in our case it was Bitbucket, when something changes in this Git repository, this tool will trigger and will apply all these YAML files that are in this Git repo to this Kubernetes namespace. And you can see that, yes, Bitbucket in this case is a central component. However, it's not this central component that has to have access credentials to all our Kubernetes clusters, but it's actually a tool that's running inside Kubernetes, and multiple of these tools that have only read access to the central Bitbucket repository. This means our security profile has been improved a lot by actually simplifying things and not having a single point of well, it's not really failure, but a single component that would have access credentials to many different data centers and clusters. And additionally to this, of course, here is the whole workflow part, of course, that I already talked about, where developers are running their CI pipelines, making changes to these Git repos, and whenever there is some production change that needs to be reviewed, operations can be checking these Git repos. It's interesting to mention that we did run into the problem of having a bit too many Git repos. So operations was a bit unhappy about the fact that there were like 50, 60 Git repos they had to be checking. But that is also a problem of these heavyweight change management processes. Basically, if you want somebody to be reviewing every single change to production, and there are many changes to production, then yeah, it's going to be a problem whether you have many Git repos or not that many Git repos. But the nice thing about GitOps is that it allows this heavyweight change management process, but it also allows you to do the lightweight change management process where your CI pipeline just updates the Git repo and the changes immediately happen. And in that case, the Git repo will be just an audit log and a central source of truth. So how do we do the synchronization? Oh shit. Sorry, this always happens with Google Slides when I push the back button because I want to go back to the previous slide, and then it's actually a back in the browser and it just cancels the whole slide. Where were we? Here. Yes, I just wanted to show this part here that we are now going to be talking about this component that does the synchronization between the Git repo and the Kubernetes cluster. So, how does this synchronization work? One way, there is actually multiple ways to implement this, and all of them are pretty simple. One is we can just use on the Kubernetes cluster, we would have, let's say, our namespace with our application and other Kubernetes resources. We would, in another namespace, we would be running some CI tool like Jenkins, for example, or GitLab. And inside that, we would have a pipeline that runs the synchronization script. So here is the GitOps repo with the YAML files, and this synchronization script gets a webhook notification, does a git pull, and does a kubectl apply to apply all these YAML files to the namespace that it's supposed to update. This is actually pretty simple to implement. The only complications are, how do you really see that it has been really finished? The deployment has been finished, so the script will start a bit growing and getting more complex if you keep adding more features to it, and also to see an overview of, let's say, what failed, what succeeded, and so on. Another way to do this is to use a tool called Flux. Flux was actually the original GitOps synchronization tool made by Weaveworks. So Weaveworks kind of invented GitOps, and they created this tool called Flux. It's a very simple tool. Actually, now they are working on version 2 that will be more sophisticated, but the original one is very simple. It is basically a small binary that connects to a single Git repo and does the synchronization. Does the kubectl apply, basically pulls the YAML files, does the kubectl apply. It can do fancy things like this could be Helm charts also in this GitOps repo. It could be customize templates also, so it can work with different formatted files and applies them to the namespace. And because Flux can only connect to a single GitOps repo, you would have as many Flux instances running on your cluster as you have GitOps repos. But this is not really a problem, as this is a pretty lightweight tool. The only problem is that you would have to manage the provisioning. Like every time you create a namespace, you also have to create Flux, you have to hook it up to the Git repo, and so on. Finally, or not really, no, this is there is going to be one more tool after this. So ArgoCD is the big brother of Flux. It is a tool that will become your central GitOps synchronization tool. Basically, it can connect to many Git repos. It can sync to many namespaces. And even if you wouldn't want to use the pull method, but you would want to use this ArgoCD to also sync to other clusters, so it would have the credentials to those other clusters, you can do that too. And also ArgoCD has a very nice UI, so you can go to that UI and see all your synchronizations happening and what's going wrong, what's working, what's not, and all kinds of things. And it has all kinds of advanced features, also filtering what kinds of resources you can use in your YAML files and so on. So ArgoCD is currently my preferred tool for this because it has all the options and it works really nicely. Finally, the biggest tool that does a lot of things is JenkinsX. Don't confuse it with Jenkins. It's from the same people, like the same company who is making and supporting Jenkins. However, it has nothing to do with Jenkins really. JenkinsX will live inside a namespace on your Kubernetes cluster and provision a whole lot of tools for like a fully fledged GitOps process. So I was showing you, the simplest GitOps process. But what happens if you have Helm charts? What happens? How do you manage your secrets? And all kinds of questions remain unanswered because they don't fit into this talk. Well, JenkinsX has an answer to all those questions. So JenkinsX is a super opinionated tool that will not only do the synchronization between GitOps and your namespaces, but it will actually also implement your CI pipelines. It will build your images, push the changes to the GitOps repo, and then also apply those changes with a different set of pipelines to the cluster. It implements everything using Tecton, which is a Kubernetes native CI pipeline execution tool. And then it installs like Nexus even, and HashiCorp Vault, and Chart Museum for Helm charts. So it does a lot of things. It's only for... unfortunately, it sounds like this is like the enterprise tool, but actually it's not really, because it's exactly missing the enterprise features. So in a way, it covers all kinds of functionality, but let's say one JenkinsX instance works only for one team. There is no multi-tenancy to segregate teams from each other. For example, ArgoCD has that. And that makes JenkinsX kind of like in an awkward position between not really being an enterprise-ready tool, but having like lots of functionality. So I recommend JenkinsX more as a tool to play around and to learn GitOps. If you would have like a complex scenario, JenkinsX might get you into trouble where it's doing like 80% of your things, but then when the rest of the 20% you just can't get done because it's getting in your way. Which Git server to use for GitOps? The answer is doesn't matter. All of them work perfectly fine. So you want to have like nice user management capabilities, pull request process capabilities, but Bitbucket, GitHub, and GitLab all provide these things, so there is no real difference between them. And yeah, as I said, getting started with GitOps, we were heavily inspired by when building our GitOps system. We were heavily inspired by JenkinsX, but we were not able to actually use JenkinsX for it. But at the same time, it is evolving, and this was like 2 years ago. So to wrap up, GitOps really will change how you think about CI/CD, about release management, about change management. It simplifies. The nicest thing it does for you really is there are more like heavyweight tools like Exa release, for example, that can do your release management and so on. GitOps is for those people who like to put different tools together to have a more modular architecture where it's not one tool taking care of everything for you, but you use like off-the-shelf simpler tools to build a more complex system. For example, you can use whatever CI tool you want. This can be Jenkins, can be GitLab, can be whatever you like for CI pipelines. You can use any Git server that you like. You have a whole bunch of choices for how to do the synchronization between the Git repo to the Kubernetes cluster. So all parts of the system are free to customize. There is no hard dependencies between them, and it doesn't even really have to be Kubernetes. Kubernetes is the most it's a very good tool for GitOps because of the declarative configuration. However, for example, Terraform would work too. So whatever you're provisioning with Terraform, you probably are already doing GitOps with it, by the way, because with Terraform, you probably are putting your Terraform files into Git. What you really need to do to make GitOps work is that you have a fully automatic process to also do the applying of the changes. So the very important part of GitOps is that once the Git repo changes, there are no more manual steps to execute between Git and whatever environment you are applying changes to. So the manual stuff the approvals and everything has to happen on the left side of this. And once Git changes, that's the intended state, and only automated processes should be running to make that state happen in the on the real environments. So with this, we got a large German enterprise company a bit closer to the clouds. And this was a really nice project and a lot of learning. And GitOps, ever since, at the time, it was like 2 years ago, we were a bit worried about like what kinds of things will we trip over with GitOps. And it's not like there are no problems with it. But ever since then, it's just getting more and more popular. More and more tools are supporting it. I'm even seeing some tool developers who are like not GitOps based, but now they have to like become a bit GitOps based too, because it's such a buzzword now and everybody is like jumping on board. So definitely, if you have not tried doing GitOps, do check it out. Yeah, please check out our book and our cmpatterns.org website. And that's it for today. Here are some links to GitOps tools. You probably can't type this really fast, but I'll be sharing the slides, and you can also just go to our website and Google GitOps. There is actually more than these two posts there. And you can follow me on Twitter. I'm actually going to be having a discussion about the downsides of GitOps on next Monday with Viktor Farsik. So thank you very much for listening. I hope you enjoyed this talk and learned something new. Oh wow, the applause is a nice touch. I like that. I haven't heard that for a long time.
Yeah, thanks, Adam, for the presentation. Thank you indeed. We have a number of questions, actually. So you mentioned the negatives of GitOps, and we have a lot of questions about, top negative features. Maybe you can just voice a couple of them.
Okay. Top. Interesting. That's a good question. Definitely one problem with the approval process is, and that's actually a bit of a general problem with this kind of a change approval processes, and with GitOps definitely doesn't solve and probably makes even a bit worse, is that all you see when a development team initiates a change to production and operations wants to review that change, right? So the development team will initiate a change saying, I'm deploying image version 5.3.4, replacing image version 4.2.1. Now, what the hell does that really tell anybody about what kind of changes are going to be happening on production? It tells that, yeah, it's only the image that's changing, that much operations can see, but still this change management process makes kind of like an illusion of control, really, than an actually a reasoned way to approve changes. However, I'm not really sure if this is a problem of GitOps or generally this kind of production change management processes. Another problem is that you're depending on how you structure your Git repos. In our case, we structured the Git repos per namespace, which made very good sense because then for every environment we could set up different access rights. So we could say that different people have access to changing the production Git repo than the development Git repo. The development GitOps repo, anybody could change from the development team, while the production, of course, only ops could change. But if you want to but with this, we of course got a lot of Git repos and per team, per environment and so on. And if you now want to see like what are all the changes that this team has made, then you have to like dig through Git history on several Git repos. So the whole, and even when you, let's say, disregarding the problem of having many Git repos, because let's say you only want to look at the production ones, which makes it easier. Even then, if you like, Git history is not exactly a structured log of changes, right? So you basically, Git history tells you that text files have changed, and if you like dig into a concrete change, then you can see diffs of what has changed in a text file. So if you want to see, let's say, all the image changes that have happened, or want to have like a statistic of how frequently did some images change, then this Git history doesn't really give you that. It really gives you an audit log where if you really want to, you can find something, but it doesn't like give you like a nice overview. But then, of course, you can add these things. It just kind of doesn't like really come out of the box as nicely as you want. And the third one I would mention, and that is really with the distributed nature of GitOps, this pool model. The pool model, of course, I said, gives you very good security benefits. However, the problem is when a development team's CI pipeline finishes and pushes changes to Git, what do they know at this point? All they know is that they have pushed changes to Git. They don't really know whether their application has actually been deployed, started up correctly, a rolling upgrade has gone well, and all these things. So this is, I think, the biggest. Actually, I would put this on first place, because this is truly a GitOps problem, basically, with making the deployment process a distributed system. So the feedback loop from the production environment, where, let's say, an application startup has not happened, you have to, and you don't really have any nice options to work around this problem. You have options to work around this. We did work around it. But there are no like simple, and yeah, you just do this and you get that functionality. So it's a bit hard to see whether your deployments have succeeded. Yeah, that would be my answer. Pretty long answer. I hope that was.
Thank you, Adam, for a detailed answer. And if you can tell us a couple of words about those GitOps operators. Do they monitor the registry in some way? Are they responsible for monitoring the registry?
Actually, Flux has a function where it can monitor the Docker image registry. I'm guessing that's what you're asking. And yeah, so imagine you're controlling things through your Git repo, but then you're also controlling things through your image registry. So Flux can do it that you basically in your Git repo, you only have like the YAMLs, but the image version actually comes from the latest image version that's in the registry, which is kind of for like development purposes or whatever, it's a very like faster flow where you don't have to mess with Git commits for every little image change, right? So actually, yes, GitOps is a bit cumbersome for a development workflow where you're like making changes to an image every 2 minutes, because you're just like, changing, testing some code and whatever. And that all those changes have to go through like a Git commit process to be applied to the cluster and so on. So it's a bit of a hassle, and Flux fixes that by, instead of like watching changes only in your Git repo, it automatically deploys any new image that goes into the Docker registry. The downside of that is, of course, that then you're breaking the GitOps principle that you're controlling your environment through Git. Basically, all those changes that are happening to your environment because something has changed in the Docker registry are now basically not recorded in Git. Or you can ask Flux to actually push those changes back into the Git repo. But then it's like kind of even more weird, because then Flux is pulling changes from your Git repo, but also pushing changes to your Git repo, and it all becomes like, not that great. But the option is there. So I guess this is pretty good for like development workflows.